Okay, we're looking at solving two equations, one that's linear and one that is non-linear. So for example, if we had a linear equation that looked like this, plus 4y equals 1, and then a non-linear equation that looked like this. We know that it's a non-linear equation because it contains an x squared or something to be squared in it, but also if it contains an x times a y, it's also a non-linear equation. So you know from Junior Cert what your linear equations usually look like. It's a simple something x plus something y equals a normal number. And there's no two variables being multiplied by each other, and the x's and the y's, there's no to the power of 2, to the power of 3, anything like that. So when you're solving them using the graphing method, you're just going to take a look at where they actually intersect. Just like how we've always done simultaneous equations, you find two answers there. So you just take the x value and the y value, and the x value and the y value of both of them on the graph, and there are your answers. Now, if you wanted to solve them mathematically, we use simultaneous equations. Now, this is slightly different because in simultaneous equations, they're usually in the exact same format with an x over another x or a y over another y. Or recently we've looked at three variables where it's xyz, xyz, but there's no powers involved. So with the powers, it's a slightly different method. It's called the substitution method. So what we're going to do is we're going to rewrite the linear equation in either terms of x or in terms of y. It depends on which one suits us most. So let's just write the equation 1 in a different way. So we're just going to let x equal 1. We're going to bring that 4y across the equal sign. It's going to turn into minus 4y. So we found another way of writing x basically. 1 minus 4y. Or if I did it in terms of y there, we're going to have 1, bring that x across, it turns into a minus x, and then we divide the whole thing by 4. So we have two ways in which we could substitute x or y into this second equation. Now the easiest one is the one that is not the fraction, unless the coefficient, which is 3 here, is the same as the denominator here. They might cancel. So I'm just going to rewrite now my second equation, which is 2x squared plus 3xy equals 35, using my new way of writing x, which is 1 minus 4y. So I'm going to write 2x squared, right? I'm going to write in 2 times 1 minus 4y to be squared, plus 3 times 1 minus 4y times a y equals 35. So we're just going to expand that bracket out. And then multiply this whole section together. So you can do the brackets first. 1 times 1 is 1, minus 4y plus 16y squared, plus 3 times, and then multiply the y in. It's going to be y minus 4y squared equals 35. Now we're going to multiply the 2 in. 2 minus 8y minus 8y plus 32y squared plus 3y minus 12y squared equals 35. I'm just going to clean it up. So look at the y squareds first. 32 minus 12y squared is 20y squared. Now you look at the y's. Minus 8y minus another 8y plus 3y. It's going to be plus, sorry, minus 13y. And then look at the numbers. 2, and you're going to bring that 35 there. Just leave it there for the moment. So you're just left with plus 2 equals 35. Okay. So what I would do is I'm going to bring all of them to one side. So I'm going to bring 20y squared minus 13y plus 2 minus 35 equals 0. And let's clean it up again. So you're left with a quadratic. So to find the two y values, you're going to factorize it. So you'd first check if there's anything you can divide the whole line by, and there's not. So we're just going to go straight into factorizing it. So 2 brackets, and we're going to have 20y in one bracket, y in the other bracket, a 1, and a 33. Fill in the signs then, y and a plus. Now to solve them, we need to let both brackets equal to 0. Okay, so we have 2 y values there found. Now we just need to get the 2 corresponding x values. And we can do that by using the linear equation. So we don't need to put it into the other equation that contains the power. So we have 2 y values. So let's find when y is equal to 33 over 20 first. So just some maneuvering going on there. We get an x value to be minus 28 over 5. So we'll do the exact same thing now with our other y value, which is minus 1. So the points then which they cross over are, we have our x value and our y value. And then over here we have an x value and another y value. And that's it solved. So the points where they cross over, the curve and the line, are those 2 points there.